This video covers the concept of impulse. Impulse is delivered by a force when it acts on an object over some time interval. The equation for impulse is simply the product of the force and the change in time. And take note here that the variable for impulse is a capital J. The units for impulse is a Newton second. This makes sense because the SI unit for force is a Newton and the SI unit for time is seconds. Impulse is a vector, as you can see by the arrow over the J, and this means that we must always break it up into the x and the y components. So let's do a quick example. A ball is struck by a bat. Calculate the impulse if the ball is in contact with the bat for 2 times 10 to the negative third seconds, and if the bat exerts a force of 5.5 times 10 to the third newtons. So, what we can do here is we can plug in the force value and our delta t, our time value, into our impulse equation. Force is 5.5 times 10 to the third newtons. Time is 2 times 10 to the negative third seconds. And when we multiply that out, we find that the impulse delivered by this force is 11 newton seconds. Let's do another example. A 5 kilogram mass is pulled across a rough horizontal surface with a kinetic friction force of 10 newtons. And this mass is pulled by a rope that has a tension of 30 newtons. Calculate the x and y components of the impulse over the course of 3 seconds. So first, if we look at our free body diagram, we see that this mass has a normal, weight, tension, and kinetic friction force acting on it. So let's first calculate the impulse in the x direction. To do this, we will find the impulse delivered by the tension and kinetic friction forces. To find the impulse delivered by the tension, you simply multiply the tension force by time. Tension is 30 newtons, time is 3, and we see that we have an impulse of 90 newton seconds. Next, we can calculate the impulse delivered by the kinetic friction. Take note here that the kinetic friction is going to be a negative value, and therefore giving us a negative impulse. Very important. You can also be asked to calculate the total impulse in the x direction. And there are 2 different ways to do this. The first way is you can simply add up all the impulses delivered to the object by each of the individual forces. So here we would have just 90 minus 30 to give us a total impulse of 60 newton seconds in the x direction. Or you could simply just multiply the net force in the x direction by the change in time. So here we would do tension minus kinetic friction times delta t, and we would still get 60 newton seconds. Alright, and lastly, we can calculate the impulse in the y direction. And to do this, we're simply going to calculate the impulse delivered by the normal and the weight force. And if we look at this object, we know that the normal force is going to equal the weight force, so the normal force is going to be 50 times 3. So the impulse delivered by the normal force is 150 newtons per second. And then the impulse delivered by the weight force is going to be negative 150 newton seconds. And to find the total impulse, you simply add these together, and we would just get an impulse of 0 newton seconds in the y direction.